the first sort of like lesson is on subsetting data. So yesterday we saw how to like build vectors, how to build data frames, how to explore them a little bit. Let's see now how to like slice and dice and access and pull out individual individual or multiple elements from the different data types that we've seen. All right. So let's play around. Let's create a vector to play with. And this is copied directly out of the learner notes, right? So we've got a numeric vector x that has some numbers in it. And I've done something a little additional. I've added some names to this character vector. So if I look at x, at this numeric vector, sorry. So if I look at x, 5.4 is now associated with the name A. If you think about spreadsheet-like data, it would be like your column headers at the top. A has a value of like 5.4. So let's first see how to access elements using indices. An indice or an index is a numeric value that indicates a physical position that a number is in. So if I want the first element in X, I'm going to submit X bracket 1. Bracket notation is we're pulling out elements of whatever thing we're accessing. Here, we're using it by an index. So we could get the first, we could get the fourth. So see, it's pulling out the fourth reading from the left, the fourth element in X. We could do multiple elements at the same time using that collection operator, C. So here I'm pulling out the first and the third. But I can't pull out something that doesn't exist, right? There is no seventh element to extract. And something that's different from some other programming languages like Python, our index starts at 1. Python index starts at 0. So if you try to pull out the first element by using 0, thank you, Juan. It's going to be like there's nothing there. It won't give you a warning. It won't give you NA, which is missing. So this is where things like length, number of columns, number of rows comes in. So you know how many, you know how many elements you have available to pull out. Okay, so that's how we can pull out and extract like one or multiple elements at a time. What if I have 10,000 elements and I want all but like 4 or something? So if we want to skip or remove elements, we use a negative index. So say X minus 2 will return X except the second element. We can do the same with multiple by saying, look, I don't want the first and I don't want the fifth. Well, notice I've got my negatives on both indices here. It is perfectly reasonable to think that you could put a negative in front of the C and say, look, I want to exclude everything. I want everything except 1 and 5. And so why don't I put the negative sign outside the C? Okay, hold up. That is a change in how R behaves, because that should throw a warning. It's a quality of life improvement. And this is kind of it's a cool but sometimes slightly frustrating piece aspect of R is under current and continual development. So there are things that like, hey, you can't do this because R doesn't let you, even though, we really would have liked it. And that's how we think about it as users. But the way R was programmed to begin with was like, no. Here's an example of likely a quality of life upgrade. Because wait. Nope, I'm getting ahead of myself. It's this one that doesn't work. That's the one that doesn't work. So we could have pulled out, if we go 1 to 3, using the colon to go 1, 2, 3, we can pull out a sequence and we could select off a collection operator, but we can't. This is trying to make a sequence between -1 and 3, which includes 0 and -1, and there are no elements at position -1 and position 0. Yeah, sorry. Yeah, exactly.
Negative parentheses 3:5.
You're saying you can do -3, 5 like that? Yes.
Or
Technically true, you do not need the C because colon notation makes a vector of all numbers inclusive. And so this will pull out everything that's not 3 and 5. 3, 4, and 5, everything between 3 and 5. Drop everything between and including 3 and 5. Positions. Because -1 to 3 creates a vector that includes 0 and -1 as a position. And those don't exist. There is no negative position. X by itself, still, I haven't modified it. I have not modified X. I just dropped it and exploring it, right? Remember to overwrite or to update X, to make the change permanent, we would have to use the assignment arrow to overwrite X. Now, if we look at the vector X, we no longer have column D. We no longer have object D. So, first challenge of the day, go back and recreate X. So rerun the code so that X has all 5 elements again. Then by yourself or work with a partner next to you. Come up with 2 different ways to get the output that's shown in the learner notes, where all you have left is B, C, and D. Don't forget to recreate X first, so it has all 5 elements. What do we got? I think, oops, there we go. I think, Kayla, what you might have been talking about was this piece right here. All right, so let's see, challenge 2. What do we got? We needed to, let's see, people in chat, what do you got? Which code? How are you going to, how did you figure out how to make only pull out the elements B, C, and D? A lot of options. Let's see, we have, oh, let me recreate X first. So I have all 5. X, C, -1, -5. I guess I like should have given a example that I didn't already do, huh? X 2 to 4. Yep, pulling out the middle pieces. Or even listing them all out, C 2, 3, and 4. Solid. Cool. Okay. So I named this was using it by the position itself. I named these specifically. Let's do this. Subsetting by name. Make sure, yep. Don't forget those 4 dashes at the end help create a nice outline in your code. So we named X. And I can figure out what those names are by using the names function. And so I can, if I want the second column, if I don't know B is the second column, or say you're working with a data set that has like hundreds of variables. I don't know, I want this column, I want income or something like that. I don't want to count that it's the 47th column. So I can extract, I'll just make it by name. So I can pull out elements A and C by specifically calling them by name. Notice I'm using quotes around. I'm still using that bracket notation, but I'm passing in a character in quotes, A and C, because that's the name. Those are the names of those elements. There's another more versatile function, or a more versatile way of doing this, which may seem like it's a lot more code right now than what it's worth, but we'll be seeing this operator later, and it'll be much more useful in bigger situations, is this. And I'm going to go through what it says in a second, but please copy from the learner notes. So we saw that names, the function names pulls out all the names of the data, all the names of the vector, A through E. This in says it's like a if it equals a oh, I feel like I missed something. Okay, if it's A or C, if the names is in this vector, so this is kind of a complex statement, and it evaluates it from the inside out. Like the first thing it does is find the names. Then it creates a true false vector for every one of those elements, every one of the names, and says, hey, is this name in the list you gave me? All right, so A is in the list, B is not, so it returned a false. C is in the list, it returned true. D and E were not in my list, it returned a false. Then that bracket notation returns only the elements that are true. We're going to see that again in a minute. Using names is usually more reliable because the position numbers can change when you're working with data. You can shift around columns. And so what was column 4 may not be column 4 anymore. Now the thing is if I want to skip a named element, we can use negative. Well, you would think we could use a negative operator, but it doesn't know how to negate a character. Like, what is negative A? So we have to use that. We'll have to use a combination of tactics. We're taking our names vector, and we're finding which ones are not equal to A. So I'm setting up another logical statement here. Where are my name? Pull out the indices where the names are not equal to A. Now, if you want to pull out more or drop, like say I want B and D, unfortunately the not equal sign isn't going to work because of this thing called recycling, which we're not going to get into too much. There is a link in the learner notes. You could read more about how recycling works. Won't work. But this is also where we can take advantage of that in. Use in operator and negate the whole thing. So find the names that are, find which columns where my names are in either B or D. That's going to return the trues. And I want to flip that. So I'm getting back the ones that are not true. So that's a way of dropping it. So I've been using subsetting using logical operators here. That's what's going on in the background. Like I could just give you this magic code and say, hey, put these symbols together and it does what you want. Juan. But one of the reasons we're here is to try to understand like the code and the process behind, so you can build up your own statements to do the things that you want to do. And so using logical operators. So say I have a logical statement, a comparison statement. Is x greater than 7? Right, here's my x again. 5.4, 6.2, 7.1. So if I say is x greater than 7, I'm getting a true false for every element. So this is a logical vector. So I could use the bracket notation to false, true, oops, true, false, true. Again, please don't like have to copy or type these all. These are in the learner notes to copy over. So the bracket notation is going to pull out, it's going to return only the values that are true. So we see we get A, the third and the fifth were true, corresponds to C and E. Now putting those two together is what we've been doing with the names argument. That logical true-false vector is happening in the background. Notation for filtering data. So filtering, that's kind of what filtering and subsetting are synonyms. Tomorrow we will see a way of filtering data using a dplyr package that has a slightly different language, but the concept's going to be the same, is we're returning rows or elements where some logical statement is true. Oops. So sometimes we don't want to only restrict, we need multiple criteria, right? I want say where x is greater than 1 and x is less than 5. So we can combine logical conditions using these two operators. The ampersand is for and, so both have to be true before the returning statement is true. And then the pipe is an or. It returns true if either one of the logical statements are true. So that's your next challenge. I kind of halfway started that for you. subset X so that the vector you get back only contains values where X is bigger than 4 and less than 7. But I want you to save this new object, assign the results of this statement as a new variable called X underscore subset. And then we'll do green stickies, green check marks when you're done, red if you need help. Okay, looking at the online people, there's only 4 that have green check marks yet. What can we help on? Don't remember how to create a new object. Awesome. So our assignment operator, the left arrow is how we make a new object. In this case, I'm overwriting X, but we get to name what's on the left-hand side. And I'm asking you to save the results as a new variable called X underscore subset. Okay. So I wanted X greater than 4 and X less than 7. That will give me my series of true falses. Right, so Trupti, what you are showing is your X subset is a vector of trues and falses, not the value of X. So this is a logical statement. Ryan, try using the, yes, the arrow operator like Jen was showing.
First I starts at 1.
So we're going to say X subset is X, where this logical statement inside the brackets determines which elements are being subset. Yep. Greater than 4 and less than 7. And so if we see, if we print out X subset, we should get A, B, and D. You guys get the same? Greens, if you got the green stickies, if you got the same, A, B, and D. So you didn't do the assignment?
Oh,
Okay. So now at the beginning of today, we talked briefly about what factors were. And so right now we've been practicing subsetting vectors. We can do similar with subsetting factors. So hold on. I want Sanjeet, can you put no, that's fine. That's fine. We'll just make a new factor. So we can use that logical statement again to say, hey, I want to pull from my vector F, I want to pull all elements where F is equal to A. I can use the in operator to say I want B and D, or how about C? Now notice I don't need to use names here because F is my factor variable and it has character values in it. Notice it's, so remember, this is a subset. It's only got certain elements. It says it's only pulling out the elements that are B, and C, but it still knows that that factor variable could have had A's and B's in it as well. And we could still use positional arguments like 1 to 3 and -1. So using positions and using names, or not names, but pulling out by the element value works for factors. Let me do a quick time check. Okay. I'm going to have to skip matrices, subsetting matrices. Those will be in the course, in the learner notes. But looking at time, I want to get into data frames because we're going to be working with data frames more often than matrices. So subsetting data frames. We have seen, so let's just check real quick, right? Structure, a gapminder. How about gapminder? There we go. we've got one, two, or let's just those dimensions of Gapminder. If I can spell it right, Gapminder, 6 columns and like 1700, 1700 rows. I could pull out by position the 3rd column, and I'm going to put a head around that. Remember, a head shows, use head to show the first 6 rows of the 3rd column, because that's what that bracket 3 is pulling out, that 3rd element. It's the 3rd column in a data set or in a data frame. So we can pull it out by position, but again, if you're working with hundreds of variables, it's going to be really difficult to remember what position. We could call it by name, like we did with a named vector. Notice the 2. Do I need the 2 brackets? Do I absolutely need the 2 brackets? I'm not 100% convinced. I do not need the 2 brackets. I didn't think so. I don't usually use brackets when extracting by variable names. I use $ notation. So if I wanted to pull out year, I would use $year. But there's nothing wrong with using brackets, and I've seen it. It's somewhat of a stylistic piece. So using $ notation to extract a variable out of a data set or a data frame using that column name is one of the most common ways. These are pulling out, hold on, data frames. This is to extract columns, but data frames are 2-dimensional. We have columns and rows. So if I want to extract rows, we can still do that positionally. I want the first 3 rows, but I have to put a comma at the end of after the where I'm specifying how many rows. So if I want extract single cell, first row, 4th column. So those brackets, they're positional. It goes rows first, then columns. So we put a comma between those 2 dimensions. So if I want the first 3 rows and all of the columns, I leave the 2nd argument blank. David, sorry, you got a question?
Yeah, I was curious, when using the square bracket notation, where single versus double, I noticed the display is different, and it looks very similar in Python. But in Python, it's because in one case you're getting back a data frame, and the other you're getting back a series, which is their equivalent of a column in a data frame. So I was curious if it's the same here, where you're actually getting back a data frame versus a single vector kind of thing.
Let's find out. I know what one of them is. I don't know what the other one is. So let's see. Double brackets. We'll pull out Gapminder. life expectancy here, and then do double brackets. So that's looks like a numbered vector. Let's see, class, or is it type of? Okay, so it's a numbered like vector where if you use single brackets, we get a data frame. And we'll get a data frame also if we use the $ notation.
That's really interesting because it's actually, I think, the opposite in Python. If you use double brackets, you get back a data frame, and the other way you get the other. So it's kind of interesting.
Oh, well, hold on. This is telling me this is an integer. Yep. Never mind. This is still, so this is a vector. This is a data frame, and this is a vector. And we care about that because there's certain things you can do to data frames and certain things you can do to vectors. So sometimes you care about how your data is, what your data type is, what your object is. I am a small bit over time. So what we're going to do is we're going to put a challenge still in the learner notes for you to maybe look at on your own when you have time. It's a what's wrong with this statement and how do I fix it type challenge. So like, here's some lines of code. What's wrong with them?